Question 1. In a reinforcement learning scenario where an agent learns to play a video game, which component represents the score the agent receives after performing an action? Option A, state. Option B, action. Option C, policy. Option D, reward. The correct answer is reward. Here's the explanation. The reward is a scalar feedback signal given by the environment to the agent after performing an action, indicating the desirability of that action. The agent's goal is to maximize cumulative reward. Question 2. What is the primary distinction between Q-learning and SARSA algorithms in reinforcement learning? Option A. Q-learning is a model-based algorithm, while SARSA is model-free. Option B. Q-learning uses neural networks, while SARSA uses tabular methods. Option C. Q-learning is an off-policy algorithm, while SARSA is on-policy. Option D. Q-learning aims to maximize immediate rewards, while SARSA focuses on cumulative rewards. The correct answer is Q-learning is an off-policy algorithm, while SARSA is on-policy. Here's the explanation. Q-learning is off-policy because it learns the optimal Q value regardless of the current policy. It learns from the optimal future action. SARSA is on-policy because its update rule considers the actual next action chosen by the agent's current policy. Question 3. An RL agent is repeatedly choosing the same action in a given state, even though there might be better, undiscovered actions. This behavior indicates a lack of emphasis on which fundamental RL concept? Option A, exploitation. Option B, policy gradient. Option C, exploration. Option D, value function approximation. The correct answer is exploration. Here's the explanation. Exploration is the act of trying new actions to discover potentially better strategies or higher rewards. The agent in this scenario is primarily exploiting its known good actions without exploring alternatives. Question 4. Which of the following best describes the fundamental difference in the output type between a classification problem and a regression problem? Option A. Classification predicts a discrete categorical label, while regression predicts a continuous numerical value. Option B. Classification predicts a continuous numerical value, while regression predicts a discrete categorical label. Option C. Classification problems use supervised learning, while regression problems use unsupervised learning. Option D. Classification problems focus on how much questions, while regression problems focus on what kind questions. The correct answer is classification predicts a discrete categorical label, while regression predicts a continuous numerical value. Here's the explanation. The study material explicitly states that classification problems involve predicting a discrete categorical label or class, while regression problems focus on predicting a continuous numerical value. This is the core distinction. Question 5. A cloud architect is building a machine learning model to forecast the monthly cloud infrastructure costs for an organization based on historical usage data, e.g. CPU, utilization, data transfer. Which type of machine learning problem is this, and which evaluation metric would be most appropriate? Option A, classification, accuracy. Option B, regression, mean squared error, MSE. Option C, classification, F1 score. Option D, regression, precision. The correct answer is regression, mean squared error, MSE. Here's the explanation. Predicting monthly cloud infrastructure costs involves forecasting a continuous numerical value, a specific dollar amount, which is characteristic of a regression problem. For regression problems, metrics like mean squared error, MSE, root mean squared error, RMSE, or mean absolute error, MAE, are appropriate as they measure the difference between predicted and actual continuous values. Question 6. Which of the following algorithms is typically used for classification tasks, and which metric is primarily used to evaluate its performance? Option A, linear regression, R-squared. Option B, logistic regression, F1 score. Option C, support vector regression, SVR, mean absolute error, MAE. Option D, random forest regressor, accuracy. The correct answer is logistic regression, F1 score. Here's the explanation. Logistic regression is a common algorithm listed for classification tasks. F1 score is an evaluation metric specifically used for classification problems, balancing precision and recall. Linear regression, SVR, and random forest regressor are algorithms for regression, and R-squared and MAE are regression metrics. Accuracy can be used for classification, but F1 score is often more robust, especially with imbalanced datasets. Question 7. What is the primary purpose of a validation dataset in the machine learning model development lifecycle? Option A, to provide the raw material for the machine learning algorithm to directly learn patterns and adjust its internal parameters. Option B, to give a final, unbiased evaluation of the model's performance after all training and hyperparameter tuning is complete. Option C, to provide an unbiased evaluation of the model's performance during training, specifically for hyperparameter tuning and overfitting detection. Option D, to ensure that the model has seen all available data during the training phase. The correct answer is to provide an unbiased evaluation of the model's performance during training, specifically for hyperparameter tuning and overfitting detection. Here's the explanation. The validation dataset is used during training to monitor performance, tune hyperparameters, and detect overfitting. It helps guide decisions about the training process itself without directly adjusting the model's internal parameters or being used for the final performance report. Question 8. During the training of an image classification model, a data scientist observes that the model's accuracy on the training dataset is continuously improving, reaching very high levels. However, the accuracy on the validation dataset has started to decrease. What does this scenario most strongly indicate? Option A, the model is underfitting and needs more complex features. Option B, the learning rate is too low and training is progressing too slowly. Option C, the model is overfitting the training data and losing its ability to generalize to new, unseen examples. Option D, the validation dataset is too small and not representative of the overall data. The correct answer is, quote, the model is overfitting the training data and losing its ability to generalize to new, unseen examples. Here's the explanation. When training accuracy improves significantly while validation accuracy declines, it is a classic sign of overfitting. The model is memorizing the training data, including noise, rather than learning generalizable patterns, which negatively impacts its performance on unseen data. Question 9. Which of the following practices is crucial to prevent data leakage between training and validation datasets during feature scaling? Option A, using cross-validation instead of a single train validation split. Option B, calculating feature scaling parameters, e.g. mean and standard deviation, only from the training data, and then applying them to both training and validation data. Option C, randomly selecting samples for the validation set that have never been seen by the model. Option D, monitoring the model's performance on the validation set after every epoch. The correct answer is calculating feature scaling parameters, e.g., mean and standard deviation, only from the training data, and then applying them to both training and validation data. Here's the explanation. Data leakage occurs when information from the validation or test set inadvertently leaks into the training process. Calculating feature scaling parameters, like mean and standard deviation for normalization, from the entire data set before time splitting is a common source of leakage. By deriving these parameters only asterisk from the training data and then applying them consistently to both training and validation sets. You ensure the validation set remains truly unseen during the feature engineering steps. Thanks for watching. Please subscribe to my channel.